What's a number what's one number you put in the diagram?
24.
24. Where'd you put the 24?
Along the entire bottom.
Along the entire bottom, like
Yeah.
like this right here?
Yes.
So that right there is 24? Okay, I'll put it like this. Nice. What else did you put in? What's another number somebody else put in?
The 18 along the sides.
The other side, like
Yeah.
this? So it's 18 from there to there? Nice, I like that. Any other ones? Oh wait, the bottom of the box is 12 by 18. What does that mean? Is that labeling correct then? Did I label that in the right place?
No.
No.
That's for example. If
Ah.
we're using 3 inches.
Wait, no, that's still right.
So it
The
says
piece of cardboard is 24 by 18.
the whole piece of cardboard is 24 by 18?
Yeah.
Oh, okay. Sure. Okay. So this is correct right here, 18?
Yeah.
Yes.
Nice, okay. Okay, the bottom of the box is 12 by 18. Nice, got it. Nice, so where's that 12 by 18 going to be?
On the inside.
On the inside. So this right here is the 18, and then what's this right here? The 12. Nice, okay. And then we know it's 3 all the way around, right? So it's like 3, 3, 3, 3, 3, 3. Lots of 3s, right? Nice. What is the volume of the box formed when 1-inch square tabs are cut? So how do you figure that out?
So now instead of the 3s everywhere, it's 1.
It's place 1, and does that change the 12s and the 18?
Yes.
Yeah, so if you change the height, like if you change a 3, the 12 and the 18 are going to change, right?
Yeah.
What's the volume formula? Length times width times height. So you have to figure out the length, width, and height of it. So we know the height is going to be 1. What's the length going to be? The length is the longer one. What's the length going to be? 22. And what's the width going to be? 16. How'd you get 22 and 16? You subtracted double the height, right? Because it's going to be on both sides. Times what? How high is it? 1. So it's 22 times 16. How many? Anybody have that?
352.
So it's 352 inches what? Cubed. Nice. What's the volume of the box when 2 inches are cut? So that's going to be volume is equal to what? 20, right?
Yep.
20 times 14 times.
2.
What does that come out to be? Anybody have that? Anybody else?
560.
What does it come out to be? 28 times 20. 28 times 20 is going to be 280 times 2 is what? I think it's 560.
Yeah.
Yeah.
560 inches cubed. Are we good with that?
Yep.
Is that okay? It's okay. That's what happens. You just got to do it. Come on, break it down. Kids, you should be able to, if I ask you, when I do this, if I did this in my head right here, it would be 20, not 24, right? You have this right here. I would have 20 times 28, right? But this is what I go through in my head. What's 20? That's 10 times 2, right? Times 28? Well, what's 10 times? I would do these two first, and what do I get? 280, and then double it, so I got 560. That is my mental thought process when I break it down. I like breaking it down to tens if possible. What is the volume of the box when 5 units are cut? What do you get? Volume is, what, 14 times what? 8 times 5, yep. So that's going to be 14 times 40, which is 140 times 4, which is what? I think it's 140 times 4, right?
It's 560.
560 again, right? That's pretty cool. Okay, nice. So what do you think they're going to ask next?
Where is it?
What's the maximum? So if you're going to maximize this, you need to write an equation. If you're maximizing area, you need to write an equation for what? Area. So our general equation is volume equals length times width times height, correct? And we want call the side of the square, what does it say?
Call the height x.
So they mean height, right?
Yeah.
So that means height. The squares are the corners, so it is the height. Okay. So we therefore know, I'm going to get off the highlighter, we have volume is equal to length times width times x, but we need to write L and W in terms of x. What is L going to be in terms of x? Look at the diagram here. If these turned into x's right here, what would the length be in terms of x? Well, what's the total amount you have? 24. 24 what? Plus 2x? You're taking away, right? So in this case, we know that length is going to be 24 minus 2x. What's the width going to be? Very similar. 18 what? Minus 2x. So then what do? All we do is we take both of those and plug it in, and you end up with 24 minus 2x times 18 minus 2x times what? X. Do we have an equation that's entirely written in terms of x? We do. We have an equation that is entirely written in terms of x. Fantastic. Fantastic. So if we want to find out what do we want to find here? Are we minimizing this or maximizing it? Greatest possible area, greatest possible area. Nice, okay. So at this point, we would need to do what to this? Yeah. Find the derivative. So our next immediate goal is to find the derivative. But before we do the derivative on that, what should we do first? Do that for me. Simplify that first for me. Simplify that as much. Did you expand it pretty carefully? Yeah, if it was me, I would take that x and multiply it in first. That's what I would do first. I would take this x and go like this. Either way, you have 24 minus 2x times what? 18x minus 2x squared. And then you have to multiply everything by everything. I just took that x and multiplied it in there. So now if I do it now, what do I end up with? 24 times 18x minus 24 times 2x squared minus 2x times 18x plus 2x times 2x squared. What do you think the easiest way to mess this up is?
Signs.
The signs by far. So then, yes, you could pull out your calculator right now. What's that? What's 24 times 18? Anybody have that? 24 times 18?
432.
432x minus 48x squared minus 36. I can almost do that. 36 what? 36 36x squared plus 4x what? So do we have any like terms in there?
Yeah.
I think so. We have this one right here, and we have that right there. So what do we end up with? Volume is equal to, I'll put it in descending order, 4x cubed minus what? 84x squared plus what? 432x. So yeah, that's in terms of x. So now what should we do to that? Now what should we do? So we've simplified. Now what should we do? So now differentiate. No, those are bigger numbers, but is that a relatively straightforward? Is that a relatively straightforward equation? Is that a relatively straightforward equation? It's relatively straightforward. The numbers are bigger, but that's the only thing that's annoying about it. So when we take the derivative, we get v prime of x. What do you end up with? 12 what? 12x squared minus 168x plus what? 432. And now we're interested in where that equals what? 0. So we have 0 equals this thing. Okay, we're cruising along here. Hey, at least they're even. What could we factor out of each of those? What can you factor out a 4? Does 4 work? Can you I think you can factor out. Can you factor out 4? I think so. So yeah, 0 is equal to 4 times what? 3x squared minus what? 42x plus 108. Can you factor anything else out? Can you factor out? I think you can factor out a 3. You can't? Really? I think you can factor out a 3. What do you get? X squared minus what? Come on, you can do it. 14x plus what? 36. So what do you have here? We have 0 is equal to 12 times x squared minus 14x plus 36. Is that a lot nicer now? If that's true, can 12 ever be 0?
No.
Straightforward question. Can 12? No, it can't. So what equation are we solving now, Liv?
0 equals
Yep.
X,
Yeah.
X squared minus 14x plus 36.
And what's the method we like to start with if possible? We love to see if it's factorable. And why is that the nicest type of quadratic to try to factor? Why specifically? What about that is the nicest thing ever?
There's no coefficient.
Well, there is a coefficient. What is
Well,
it?
it's 1.
The leading coefficient is 1. Exactly, Liv. So we're looking for two numbers that multiply together to get 36, but add together to get
14.
negative 14, right? So we know both numbers are going to be what?
Negative.
They're both going to be negative, right? So we could do, what are the factors of 36? What do we have here? We have 2 and what? 18. 18 factors into what? Like 2 and 9. What is this? 3 and 3. So you look at that and you try to find one that works. Are there any? Does it work? I really want it to, right? We've been cruising through really nice numbers, so I'm optimistic that it is, but here's the thing. Just because it looks like it, so do you see any pairs that are going to work? You could try testing a bunch of them. So unfortunately, what do you have to use? When you do the quadratic formula, I need you guys to remember, do not just write out the whole thing. Stop. Everybody pause. Stop writing out the whole quadratic equation. What do I like you to compute first? Do you remember what it's called? The discriminant, which is b squared minus 4ac. What is b in this case?
Negative 14.
So negative 14 squared minus minus what? 4 times 1 times 36. So what's that going to come out to be? What's 14 squared? 196?
Yep.
So we have 196 minus 4 times 36, which is 120 plus 36, which is what? 152?
One,
What is it?
What?
144.
Isn't it 144?
Yeah.
4 times, yeah, sorry.
It is
Oh.
50.
Oh, you did the whole thing. I'm sorry. I was like, I think it's bigger. So that's 52. So what's the answer going to be? X is equal to negative b, so negative negative 14 plus or minus the square root of 52 all over what? 2 times 1. So that's actually a good sign. We determined that it wasn't nicely everything's factorable, right? Is everything nicely factorable?
No.
No. And that actually, why does this verify that it's not nicely
Because
factorable?
if it was nice factor, it would
It's
be
not a
perfect
it's not a
square.
perfect square. Exactly. 52, right? So how many answers do we have here? 2. So we have x is equal to 14 plus or minus the square root of 52 over what? 2. At this point, you could use your calculator. Use your calculator and tell me what the 2 answers are to 3 decimal places. Everybody do that right now. And if you don't have a calculator, you could use the... Yeah, here's something. Can you cut out 10.6 inches?
No.
Look at our original, look at our thing here. Can someone tell me what's the biggest thing? So x could be 0, right? Cut out nothing and then we get no box, right? Theoretically, we get no box. What's the biggest thing x can be?
9.
Yeah, because if you make it 9, it just folds in half, right? You cut out everything, right? The volume is 0 in each of those cases because you've cut out 9, you're going to cut out, actually you're going to cut out everything, but your box is going to have 0 area. Why is it 9? It's half of 18, right? So here's the thing, 10 is bigger than that, so what's the only one we're going to test? 3.394. So what do we have here? We have a sign diagram here, and we do 3.394, and this is the x value, and then it's going to be the v prime value. Where's our simplified v prime? We simplified it, right? Where is it? It's right here. You see that, everybody? So what should you use if you're going to evaluate some numbers here? Please use your calculator. So maybe let's test, I don't know, 5 and 2. Try 5 and 2 and tell me what the signs are. So we have 2 areas here. We have these 2 areas right here and right here. In 3.394 because it is a nice maximum. And what do you get? What do you get? 12 inches square. Okay, so first of all, did you draw a little square? So we have a square, nice, and we cut out squares from each corner.
Oh, I know what I did.
Is that correct what we do? Oh, you can't see it? Sorry. Thank
I
you.
know what I did. I'm wrong.
You're wrong?
Yeah.
Okay. So we have this, right? So we know that each side is how long? What's the outside side length? 12 and 12, right? So if this is x, and 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 this is x, lots of x's in there, right? What's this side length right here? 12 minus 2x. And what's this one? 12 minus 2x, right? We know the volume is length times width times what? Height. So what's the length in terms of x?
12 minus 2x.
Yeah, and what's the width in terms of x?
12 minus 2x.
And what's the height?
X.
The height is x. So we have volume in terms of x equaling 12 minus 2x times 12 minus 2x times
12.
x.
Or times x, yeah.
It's the height x, right? Now you need to make sure you multiply this correctly before you differentiate. You end up with what? 12x minus 2x squared. So then you have v of x is equal to 144x minus 24x squared minus 24x squared plus what? 4x cubed. So you end up with 4x cubed. So that's that one, right? Minus what? 48x squared plus what? 0. So the only one you test is 2. You have to make a sign diagram for it. So you have 2. So you have x and v prime. Where's v prime here? V prime, we know, is right there in front of us. It's going to be, oh, here's the nice v prime right here. So we test v prime, and what do you end up with? Plug in, what's a good number to plug in? How about 1 and 3? Plug in 1 and 3. What do you end up with? 12 minus 96 plus, oh, it's going to be what? Positive. And then it's going to be negative. So it is indeed a what? Max. So then you actually have to answer the question, because the question is what are the dimensions, right? So what are the dimensions going to be? Length is going to be 8 by 8 by 2, and then the volume is going to be 64 times 2 is 128 inch cubed.
I realized where I
What happened, Sarah?
So I simplified the beginning when you're like plugging things into the equation.
How many pieces do we have here? We have a circle, and some sort of rectangle, right? What do you know about the two circles?
They're the same size.
They are the same. They are the same. So they have the same, let's call it the same radius. Sound good? Nice. Okay, what about this piece has to relate to this? There's something here. What has to relate to this?
The top has to equal this.
This has to be the circumference, exactly. If it doesn't, then it won't match, right? So we're making like a perfect cylinder. In reality, is it perfect? No. But we're going to pretend it is. Is everybody with me so far? So can you tell me what the top length of that is? What's the top length of that? So it's equal to the circumference. What is the circumference of each of those circles? 2 pi r. So this distance is 2 pi r. And do we have any idea what this side length is? We'll call it the what of the cone. What's that going to be? The height. So what's the area of this piece right here? What's the area of this piece? H times what? 2 pi r. What's the area of this of the circles right here? 2 times what? Pi what? Pi r squared. So what's the total amount of material used? So material used is going to be what? H times what? 2 pi r plus 2 times pi r squared. That is the amount of material used. What's the challenge here, though? Can someone tell me what the challenge is right here? What's the challenge right here? What's different about this equation than the other equations we were dealing with? There's one thing that's different. 2 variables. We had, like, when we did the rectangular box, we had volume equals length times width times height, correct? And we got rid of all the LW and H's and we turned them into what? X's, all the terms of X's, right? So in this case, is it obvious what we need to do? No. But do we have the equation we want to maximize? Sure. We want to minimize or maximize this? Oh, we want to minimize the amount of material. There's one number up here we haven't used yet. What have we used? The what? Oh, we haven't used the volume. What does the volume need to be? Oh, you found it. 355. What's the volume of a cylinder, everybody? How do you write the equation for the volume of a cylinder? It's the base times the height. What's the base of a cylinder? Pi r squared times the what? Times the what? The height. But what do we want the volume to be?
350.
Not 355. We want it to be what?
0.3.
Let's do it in like this. 355 times what? H. What can we do with this now? Why is that super helpful? What could we isolate, Sarah? What's the nicest one to isolate?
H.
I like isolating H. So what's H going to be? 0.355 over what?
Pi r squared.
And then where can we plug that in?
Back into the other.
We can plug it back into the other one, and now we have M equals 0.355 over pi r squared plus 2 pi r squared. Hey,
Wait, what?
go ahead. Sorry, Liv.
Never mind. Wait, what just happened?
We know this is the volume of a cylinder, right? We know the volume has to be equal to this. So what did we solve for? We divided that over to the other side. So H is this. I then took this, put it into here.
Yes, didn't you miss the 2 pi r?
I did miss the 2 pi r. Thank you. So what does it become? I'm missing something key here, right?
Yeah.
Thank you for catching that. So this gets moved over here. And what do we have now? 2 pi r
2 pi r.
times 2 pi r, like this, plus that. This looks ugly, but how many variables are over on the right-hand side? Just one. So theoretically, are we home free?
Yeah.
We take the, set it equal to
0.
We also test the, fantastic. So we're going to talk more about this later. Thanks for your attention, everybody. I know it was a little info